Hello, my name is Young-Hoon Chung, and I'm a graduate student at Dartmouth College. In this poster, I'll be talking about investigating the spatial distribution of exogenous attention, specifically comparison between within and across different visual hemifields. Exogenous spatial attention enhances visual processing at the attended location. This is known to be involuntary, stimulus-driven, and very, very fast. For example, if a car honks right in front of you, you'd automatically pay attention there. Studies that examine exogenous attention usually show an uninformative cue shortly prior to target presentation, therefore enhancing the performance of discriminating different targets. However, most studies only use a few locations, like left and right side, leaving it unclear how exogenous attention effects are distributed across the visual field. Here we are interested in investigating how spatially localized exogenous attention is. More specifically, we are investigating if there are any differences in attentional spread within versus across visual hemifields, as shown in endogenous attention literature in various paradigms. In order to investigate this question, we ran two different types of experiments. First, looking at the spatial distribution of single focus exogenous attention, and second, investigating dual focus exogenous attention. Again, in both experiments, we wanted to see if there are any differences across versus within the visual hemifield. Our experimental design is as follows. There are four possible target or cue locations equally distributed around the center. Prior to the target presentation, one of these locations was cued with a white ring for 100 milliseconds. After around 75 milliseconds, a target showed up on any of the four possible locations for 70 milliseconds, followed by a visual mask at the same location. The target here was a Gabor patch that was either tilted 45 degrees towards clockwise direction or counterclockwise direction. Afterwards, participants are asked to report which direction the target was tilted by pressing a corresponding keyboard. Because the target and cue can show up on any of the four locations with equal chance, the cues here were completely uninformative and unpredictable of target. Because there are four locations for cues and targets, this yields four different conditions. First, when the target and the cue show up at the same location, that's valid condition. If the cue shows up across the hemifield of the target, that is invalid condition. If the cue is on the same hemifield as the target, but on the other location, that's invalid within. And if they are opposite diagonally, it's invalid diagonal. Again, we are interested in looking at the spatial distribution of single focus exogenous attention here. For example, do visual cues only enhance the exact cued location, or does it spread to other locations, possibly more within a hemifield than across hemifields? We ran a lot of participants online and excluded anyone with lower than 55% or higher than 95% overall accuracy. The data shows that first, valid condition resulted in better performance compared to any of the three invalid conditions. And when comparing invalid across and invalid within conditions, we found no significant difference. In experiment 1B, we introduced vertical distractors around the target during target presentation, as many endogenous attention paradigms do when looking for hemifield effects. No mask was presented after the target in this version. In result, we replicated the same effect as experiment 1A. Both 1A and 1B showed that valid condition was better than any of the invalid conditions, which aligns with previous studies that valid exogenous cue can boost visual processing. This is also interesting because it shows that such high-powered online study can replicate what's usually studied in lab with fewer subjects. There was no difference between invalid across and invalid within, suggesting exogenous attention at cued location does not also enhance other locations, and that this is the same whether the invalid location is within or across hemifield from the cued location. Additionally, same result showed with distractors in the task, further providing evidence that exogenous attention can be spatially selective. So far, we found that single focus exogenous attention is spatially selective and there was no hemifield differences. Our next line of experiments investigated spatial distribution of dual focus attention. This is particularly interesting since if there are any hemifield effects, showing two cues within the hemifield or across the hemifield might be more sensitive in revealing interesting hemifield differences. Experimental design for experiment 2 was essentially identical to experiment 1, but this time two of the locations were cued before the target. Again, this results in four main conditions for the analysis. First, valid within is when the two cues are presented in the same hemifield and one of them overlaps with the target location. Valid across is when the two cues are presented across the hemifield and one of them overlaps with the target location. If the two cues are in the same hemifield and none of them overlap with the target, it'll be invalid within. And if two cues are across hemifield and none of them overlap with the target, then invalid across. Again, we ran participants online and excluded data according to the same criterion. When comparing the valid within versus invalid within conditions, we indeed found Q validity effect where valid within was better. However, for across hemifield Qs, valid across condition did not result in better performance than invalid across condition. If anything, it's almost like invalid across was better than valid across in the data. We also ran the same study with distractors around the target. Again, only within Q conditions showed Q validity effect. This time, valid across condition resulted in same performance as both invalid conditions. Combining results from 2A and 2B within valid condition was significantly better than invalid conditions, suggesting that exogenous attention can enhance targets within the same hemifield. Across valid was not better than invalid, showing that exogenous attention cannot really enhance targets across different hemifields. In summary, second experiments showed that during double queuing, exogenous attention can enhance multiple targets within the same hemifield, but not across different hemifields. This is very interesting because it's very different than what people have found for endogenous attention. With endogenous attention paradigms, people tend to find that it's much easier to enhance multiple targets across different hemifields. Overall, these results may suggest that there are interesting differences between exogenous and endogenous attention, in particular, how effectively attention is distributed within versus across hemifields. In ongoing work, we are exploring whether attention is divided across these two locations or instead spread broadly within the hemifield. Please feel free to check out my poster session for more information on that. Thank you very much for listening.